Uh, Hi, everyone. Thank you very much for joining the session today. My name is Yoon Park, a UX designer at Microsoft Windows Mixed Reality Design team. So I'm very excited to be here today to talk about some of the latest building blocks for creating apps for Windows Mixed Reality. So Mixed Reality Toolkit is the open source project where you can find foundational components and building blocks for common interactions and UI controls. So using these foundational controls and building blocks, you can accelerate your app development for Windows Mixed Reality, for HoloLens and immersive headset. So you can find Mixed Reality Toolkit on GitHub. When you search Mixed Reality Toolkit, you're going to find these two repositories, Mixed Reality Toolkit and Mixed Reality Toolkit Unity. So Mixed Reality Toolkit is the Uber project where we have native code and DLLs and for the core features, and also DirectX implementations. And Mixed Reality Toolkit Unity is the Unity-specific repository that we have the collection of prefabs and scripts and example scenes. This is a repository I'm going to talk about today. And when you visit the GitHub page, Mixed Reality Toolkit Unity, you're going to find important information on the landing page, such as latest MRTK release package and the supported Unity version. And also, when you scroll down, you're going to find important example scenes. So for the past several months, our team has been working hard to help you developers and creators by adding these foundational common building blocks to MRTK. And today, I picked up some of the most frequently used building blocks from this MRTK. So for these building blocks, I'm going to talk about, I'm going to introduce these quickly. Then you're going to also learn where you can find examples in and how you can apply it to your projects. So let's get started with input. So whether you're designing apps for HoloLens or immersive headset, you need to set up proper input manager to get the gaze cursor, gesture input, and the motion controller work in your content. And MRTK makes it very easy. So these are two great example scenes you can find in MRTK, input manager test and the motion control test scenes. So these are under HoloToolkit examples, input, and scenes folder. As you notice, the folder name is a HoloToolkit. This is because the Mixed Reality Toolkit was originally designed for HoloLens, so it was named as a HoloToolkit, but later we expanded to support immersive headsets, so we rebranded to Mixed Reality Toolkit. So when you import MRTK release package or clone it from the GitHub and open it in Unity project, you're going to get this new menu called the Mixed Reality Toolkit. Then under there, you're going to find these very convenient menus. And when you click this Apply Mixed Reality Scene Settings, then you're going to get these crucial components such as input manager, mixed reality camera, and the default cursor. So of course, you can also manually search and add these prefabs into your scene. So when you search mixed reality camera, you're going to get these two different camera. The difference is mixed reality camera parent has some additional components such as motion controller, teleportation, and the boundary to support immersive headset. And mixed reality camera prefab automatically detects the device type. So it both supports HoloLens and immersive headset. So depending on the device type, it configures some of the options, such as skybox and clear flags. And these are some of the other useful properties you can customize. For example, you can easily override the motion controller model with your custom model. And you can also customize the floor and the gaze cursor. So let's take a look. So now I have Mixed Reality Toolkit menu in Unity editor. When you click it, under Configure, so you're going to get these new menus. And when you click Apply Mixed Reality Scene Settings, and click Apply, then you're going to get these three components, Mixed Reality Camera Parent, Default Cursor, and Input Manager. So under Mixed Reality Camera Parent, you can see there's a camera, motion controller, and the boundary. So for the demonstration purpose, I'm going to add an object, a coffee cup object, which is one of the interactive objects we have in MRTK. Then I'm creating an empty object as a container, and I'm adding a script called Sync Content Adjuster. So this is a quite useful script which automatically adjusts the Y position depending on the device type. So because 0.0.0 means the headset position in HoloLens, whereas it means the ground in the immersive headset, the content needs to be adjusted if you want this scene run for both HoloLens and immersive headset. Now when I click play, so as you can see, the gaze cursor is on, then showing the proper visual, and also it gets the gesture input. So in default, it shows dot, and when the hand is raised, it shows the donut shape. And also when I run this scene on the immersive headset, you're going to get this motion controller with the pointer with the gaze cursor. In the same way, I can interact with the object with the trigger button. And also, this has the teleportation and the locomotion feature. So you can turn left and right. Then when you look at the motion controller under Mixed Reality Camera Parent, you're going to see this alternate control model. So you can easily override the models when you just drag and drop your custom prefab. So in this example, I'm drag and drop the brush and the pencil model. And I check those checkbox of alternate, always use alternate left and right control model. So when I play, so you're going to get this motion controller replaced by custom model. So super easy. So that is how you quickly and easily set up the input camera and the cursor using the MRTK's menu. So next, interactive object receiver. So interactive object examples show you how to make an object interactable and make it respond to the standard interaction states. In mixed reality, a button could be anything that triggers actions. So it could be a coffee cup or a balloon. So it doesn't have to be kind of 2D rectangular shape button that we had in the 2D world. And in mixed reality, it is also important to provide a proper visual feedback so that user can understand which object is interactable. So you can find the examples under examples, UX, and scenes. The name is interactive object example. So to make an object interactable, you can use this series of scripts called compound button. So these are a kind of collection of scripts that represent different elements of the interaction states. So animation, text, icon, sound, and speech, and also mesh. So using it is quite simple. On any object, you can just assign this compound button script depending on your purpose. You can mix and match and adjust the properties. And these are the interaction states available in Windows Mixed Reality. So observation is default idle state when the gaze cursor is not on the object, and also hand is not raised, not detected. Then observation targeted is when the gaze cursor is on the object, but still hand is not raised. Then interactive is when the hand is raised and with the ready gesture, with the index finger on, but the gaze cursor is not on the object. Then targeted states when both your hand is ready and the gaze cursor is on the object. So you can see the gaze cursor is showing the donut shape. And press states is when you're doing the air tap with your finger. So for these interaction states, you can differentiate the visuals so that you can provide proper visual feedback to the users. So this is one example. For example, you can make the object a little bit brighter and make it increase the tint for the observation targeted. And for targeted states, maybe you can increase the size a little bit and change the color. And of course, for the press states, you can also make the objects a little bit smaller. So you don't have to differentiate all the visual states for these interaction states, but I would recommend at least differentiate for observation, the idle states, and the targeted and press states so that user can easily understand this object is interactable. So let's take a look in action. So I'm creating a cube, and I'm reducing the size to 0.1 meter, 10 centimeter. And I'm adding the compound button script. So in this example, I'm going to add a compound button mesh because I want to play with the properties of the mesh. So when you add it, it's going to add a compound button, the base class in default together. So now you are selecting the collider and renderer. And also, in the compound button mesh script, you can assign the proper transform that you want to play with. Then I'm creating and assigning a new profile. So profile is quite useful when you want to control this theme, apply this theme to the multiple objects. So compound button series uses this profile mechanism. And so under this profile, you're going to see all these available interaction states to this object. So press targeted, interactive object observation targeted. So now I'm putting the 0.1 meter to all this scale value because I just reduced the size. That was the default value for this cube. Then I want to make the object a little bit shrink for the press states. So I'm putting 0.05 to this press states. And also, I want to make the object a little bit bigger for the targeted states. So I'm increasing the value to 0.12. Then also, you can assign the different colors of this mesh for each interaction states. So for the demonstration purpose, I'm assigning clearly different colors. So I'm assigning the green color to this targeted states, assign the magenta, the pink for the press states. So this way, you can easily customize and differentiate the visual states for this interaction states. And you can also check this smooth status change. So that allows you kind of smooth transition between the colors and the size. So when I click play, so in the editor, as you can see now the cube is responding to my gaze cursor with the proper visual feedback for the different interaction states. In the editor with the MRTK, you can simulate this hand gesture. So as you can see, you can use a mouse and the keyboard, spacebar, to control the right hand. And also you can use the left shift key to control the left hand. So you can click to emulate this, the air tap gesture. And interaction receiver is another useful script that can be used with the interactive object. So it allows you handle the events from the multiple object in a single script. So as you can see in this diagram, I have multiple objects in the scene, and I have a receiver script that can handle the events from these. Then I can do something based on the object. So to use it, you can create your own receiver script that inherits from the interaction receiver. Then you're going to have this field called interactables. Then just drag and drop, assign the object. Then in your receiver script, for the whole typical interaction handlers, you can handle events. You can identify which object triggered the action using this game object obj. So you can find this receiver example also in the interactive object example scene. So as you can see, I have a multiple object that shows a different customization example. So using this compound buttons script series. And I have this receiver script called button receiver example. And when you take a look at it, it inherits from the interaction receiver. And back in the editor, I have this field called status text. So this is a just simple text mesh to display the debug message. So I want to display the object that triggered the action and also the event type. So now I'm selecting the interactive object and just drag and drop to this interactable to assign this object onto this receiver. I'm assigning some additional buttons from the toolbar. So now, since I have all these interactive objects on the list, I can handle events from these objects. So in this receiver script example, I'm just accessing this text mesh component and displaying the object name and the event type. So when you run this example scene, you're going to see this now the status text message is displaying the object name and the message event type. So this way you can easily handle the events from multiple objects in a scene in a single script. So yeah, that was interactive object and receiver. Next, bounding box and FBar. So the bounding box and FBar is the standard interface for manipulating object in Windows Mixed Reality. So with this single interface, you can move, rotate, and scale the object in space. So you can find this interface in the HoloLens, also in the immersive headset. And the FBar is to display the contextual menu in front of the object. So as you can see, in default, it has a hide, adjust, and remove button. So when you click the adjust button, you're going to enter this gizmo mode where you can get this interface. Then you can also click the remove button to delete the object. And also this bounding box can be combined with the two-hand manipulable script. So as you can see, you can also use your both hands to manipulate the objects. So you can find the example scene under examples, UX, and scenes folder. The name is bounding box gizmo example scene. So using it is very easy. So on any object, just assign this bounding box rig script. That's all. Then you're going to get the FBar displayed. And when you hit adjust button, then you're going to get this gizmo interface. When you look at the structure of this bounding box, it combines several scripts and prefabs. So bounding box rig basically constructs this, the rig and the gizmo handle. And there's another prefab called bounding box basic. So this is a prefab that is used to display this blue wire, the boundary. And there's another prefab, FBar, which is also part of this bounding box rig. So I have a coffee cup object here, and I'm searching bounding box rig script. And I just assigned it. And now I'm searching the bounding box basic prefab and assigning it to this bounding box prefab. Then, when I hit play, so you're going to get this FBar. So when you tap this hide button, you can minimize it. You can also tap this adjust button to enter this gizmo mode. So you can scale, rotate. But in default, the object is not movable. So we kind of separated the script for the moving components. So you can combine with other script for the moving interactions. So now you can also add some other scripts, such as hand draggable or two-hand manipulable script to make it movable or interactable with the two hands. And I'm changing the option of this two-hand manipulable script to move, rotate, and scale. And also, I'm assigning the bounding box basic prefab to get the blue wire visualization. So now, when you grab the object, you can move it. And also, it shows this blue wire when I start interacting with it. And of course, this two-hand manipulation works without entering the adjust mode. And you can also combine these two interaction behavior. Still, you can use that gizmo interface. And also, you can customize the FBar. So when you search FBar prefab, and when you look at the inspector panel, you're going to get this the buttons field. So when you put the number of button, and so for each button, you can define the position and the name, as well as the texture. So this way, you can easily add your custom button to this existing FBar, the standard interface, and add your custom actions to the objects. So when I click play, so as you can see, now I have this additional my custom button, red, green, blue. So yeah, this way you can easily extend the standard interface for the object. So yeah, that was bounding box and FBar. Next, two-hand manipulation. So So two-hand manipulation allows you interact with object with using your both hands. So you can move, rotate, and scale. So it also supports both hand gesture and the motion controller. So this two-hand manipulation was introduced in RS4 HoloLens as well as a Cliphouse in the immersive headset. So as you can see, with this single script, you can make the object work with both motion controller or the two hands. So this is a quite intuitive way to manipulate object in Windows Mixed Reality. So you can find the examples under Examples, Input, and Scenes folder. The name is Two-Hand Manipulation Test Unity. Again, this is pretty simple to use. Just on any object that you want to interact with, just assign this two-hand manipulable script, and then that's all. So when you look at the inspect panel, you can also specify these options like a manipulation mode and the rotation constraint. So you can make the object rotate along with a specific axis. So I have a coffee cup again, and I'm searching two-hand manipulable script. Then in default, it is scale only. So when I click play, now you can interact with this coffee cup using your both hands. Scales up, down. Then in the option, I'm changing it to move, rotate, and scale. So you can limit the kind of this interaction mode depending on your app context. And I'm also adding the bounding box basic, which is the blue wire visualization. So this is the behavior you can find in HoloLens shell and the immersive headset Cliphouse. When you start interacting with the object, it shows this blue border. And also you can use this rotation constraint to limit the rotation axis. So as you can see now, the coffee cup is moving along only with the y-axis. So it's pretty simple and easy to use for manipulating object. Next, object collection. This is one of the most exciting components in MRTK. So with object collection, you can easily lay out an array of objects in 3D space. So you can also specify surface types such as a cylinder, sphere, and you can define the spacing between the items. And so it's quite easy and simple to use. So you can find examples under Examples, UX, and Scenes. The name is Object Collection Example. So to use it, create an empty game object and just add multiple objects under it as a child component. Then to this game object, container object, assign this object collection script. Then in the inspector, you're going to get these options. So you can change the surface type, define the spacing between the items. Then when you click adjust, it will update in the scene. Of course, you can call this adjust button, adjust an action in the script in the real time. So I'm creating this empty game object, and I just assign this object collection script. So as you can see, it has a different surface type. So I can define the number of rows and the cell width and height. Now I'm adding an object, a coffee cup again, and just duplicating multiple times. Then in this container, object collection script, when I click update, you're going to see this kind of grid layout. Now you can play with the spacing between the items and surface type. So in this example, I change it to the cylinder type. So you can play with the radius. So you can easily and quickly construct these kind of through three-dimensional layout. And this time, I'm adding this holographic button, which is another prefab part of MRTK. And again, I'm duplicating multiple times, and I'm switching back to plain surface type. And when I click play, update, then you can easily get these kind of grid layout. Now I'm adjusting the cell width and height to the object size. Then when I play, So you can easily and quickly construct this kind of the holographic UI panel. Isn't it cool? Yeah. So that was object collection. Next, server. So server system allows you combine multiple object positioning behavior and run them in specific order. So start menu is a really great example you can find. So it shows the tag along and the billboarding, as well as the constant view size. So when the start menu collides with the physical surface or other object, it moves back and forth. But as you can see, it automatically shrink or increase the size to maintain the scale. So to achieve this kind of behavior, you can use this server script series. So you can find the example under Examples, Utilities, and Scenes folder. The name is Server Examples. So to use it on any object, you can assign this server script series. So we have a server body lock, a constant view size, a radial view, surface magnetism. So you can mix and match for your purpose. So this is one example of using spatial processing with this server surface magnetism script. So using this script, you can easily snap object to a surface. So in this example, I'm using the planes that it was processed by the spatial processing. So as you can see, now I'm aligning this the panel very smoothly with the surface. So as you can see in this inspector, you can play with a lot of options like a lerping time. You can control the magnetic surface and the facing behavior, as well as other distance, like a minimum and maximum distance. So you can find these examples in under MRTK's example. Another example, so using server radial view. So using this script, you can easily position object in a spherical range. So as you can see in this example, I'm positioning this toolbar always within certain spherical range. So again, you can play with the lerping time, minimum and maximum distance, and the view degree. So it's quite easy to use and it's fun to play with. Another example, the server body lock. So this script allows you attach a position object in a kind of always attached to your body with a certain offset. So this example shows this toolbar always stick to under my waist. So yeah, you can easily position this object in a certain position. So yeah, that was server. Next, voice command.
Move this. Here. Bigger. Bigger. Smaller.
So the voice input is a natural way to interact with the object in Windows Mixed Reality. So as you can see, the HoloLens and the immersive headset shell provide some of the system default commands, like select, close, move this, face me, bigger and smaller. And with the Mixed Reality Toolkit, you can also easily define your custom voice command in your app experiences. So you can find the examples under Examples, Input, and Scenes folder. The name is Speech Input Source Unity. So to use it, add speech input source to the scene. Then you're going to get this the keywords field, so you can easily define your custom keyword. Then on any object, you can create a script that implements this iSpeech handler. Then inside the script, you can handle this on-speech keyword recognize event to do the specific action. So yeah, that is how to use voice command. And next, spatial understanding. So spatial mapping, spatial processing, and understanding are one of the most exciting features in HoloLens. So you can analyze the environment and identify the surface types, such as floor, ceiling, and wall. So this way, you can interact with the physical surface and make your hologram more realistic. So if you ever play these fragments in the HoloLens, it's one of the best examples that leverages this physical environment. So the characters are occluded by the actual physical environment. And also, as you can see, you can make the characters sit on the couch and the real-life couch. So in Mixed Reality Toolkit, you can find these 3 different examples for spatial mapping. So first one is spatial mapping example. So this is the kind of most basic one. So by just drag and drop the spatial mapping prefab into your scene, then you're going to get this visual mesh of your environment. So this is a kind of the easy and quick way to interact with the environment. But as you can see, the visual mesh is a little bit rough in this case. So if you want to, for example, walk your character on your environment, sometimes it could be tricky because there could be a hole or bumps. So if you want to get more cleaner surface, then you can use this spatial processing example. So basically plane finding. So as you can see, you can find the examples in the MRTK. And the spatial understanding is the most sophisticated one. So this example shows you how to scan a room and identify the surface type, such as floor, ceiling. So this is one quick example using spatial processing. So after initial scan, I'm getting this clean planes. Now I'm getting planes, this couch. I'm dropping a coffee cup onto this couch. Hopefully I don't spill too much. So as you can see, now you can interact with the physical surface. And of course, you can make this the blue plane as transparent so that you can make it look like interacting with the physical surface. And this is a spatial understanding example running on the same scene. So basically, it does the initial scanning of the environment, then processes it, and it gives you this kind of identified semantic labeling for this object type, surface type. So you can get the floor, ceiling, and wall. Then you can get this kind of lots of options of queries, so topology queries and object placement and shape queries. And so this is an example scene you can find in MRTK. So then this way you can position your object on a specific type of surface. So you can make the objects always placed on the table or edge of the table. So yeah, this was the source code contributed by the team who created the fragments and Yoon Concur. So it's really fun to play with. And again, the similar example that I showed before, using the spatial processing. So after initial quick scan, you're going to get these planes. Then now using the server surface magnetism, you can make your object snap to this surface, physical surface. So let me do a quick intro how to do this. So to use this spatial processing planes, you need to add a unity layer. So fortunately, the MRTK menu provides this setting easy. So under Mixed Reality Toolkit menu, under Configure, when you click this Apply Mixed Reality Project Settings, then it automatically sets this spatial mapping layer. So it assigns this number 31 as a spatial mapping plane. And when you look at spatial mapping prefab, in default, it already has this number 31 as a physical layer. So all you have to do is on the object, when you assign the server surface magnetism object, script, under there, you're going to see this surface, magnetic surface option. So on the dropdown, all you need to do is selecting this spatial mapping layer, which was number 31. So you can find this example scene under MRTK2. So yeah, that was spatial mapping, processing, and understanding. Next, attached controller. So attached controller is for immersive headsets motion controller. It allows you easily attach an object to the motion controller. For example, you can attach a UI or other interactive object. So you can find examples, great examples under one of our academy tutorial, Mixed Reality 213 motion controller. So when you look at the page, you're going to find very detailed examples of attaching the object, UI, or customizing the motion controller. And in MRTK, we have this attached to controller script. So quite easy to use. So on any object, just assign this attached controller script. Then you're going to get these options such as handiness and the elements. So you can specify the controller left or right And also you can specify the elements of the controller, like the select button or touchpad, the pointing pose. So this way you can easily attach this kind of UI to the specific part of the controller. So this example, I attached this color wheel UI to this touchpad, and I'm leveraging this axis value to select the color. And again, as I mentioned, you can find this more advanced example under Mixed Reality Academy tutorial, which is also part of the open source. So you can get all the source code example. Next, MRTK standard shader. So this MRTK standard shader is a new shader which provides various types of options, visual effect, such as glowing border and a whole light. So with this shader, you can easily achieve different types of fluent design elements, such as light, depth, and motion. And the good news is this shader is optimized for the HoloLens, so it runs on 60 frames per second. So it's a very performant, and it's a really great to play with. So you can find this material gallery examples under Examples, Standard Shader, and the Scenes folder. So you can grab the existing material, and apply to your project easily. So you can find this application example in various of the existing examples in. So this is one example, the holographic button. So as you can see, on the right side, I'm showing this compound button mesh options. Again, the same interaction states. And in this example, I'm controlling the value of this shader, the properties of the shader, the color and border width on this front panel geometry. So this way, I'm kind of providing this kind of visual feedback with those kind of glowing border and the hover light. Let's take a look in action. So I have this cube here, and I'm creating a new material. Just named it as a cube material. And I'm changing the shader to this new Mixed Reality Toolkit standard shader. Then I'm assigning this material to the cube. Then under there, you're going to see these options, such as the rendering options and fluent options. So in default, the hover light is turned on. And now I'm changing the color to make it easy to see the hover light. Then when I click play, so as you can see, when the gaze cursor is on the object, it shows this hover light effect. Then I want to play with the other properties. So now you can also customize this hover color. So when I check this hover color, and you can easily assign the different colors. So as you can see, it shows a pink color hover light on the object. It also has a lot of different options, such as border light, so you can achieve this kind of glowing border effect easily. And you can control the width and smoothness. So yeah, I can play with the thickness of the border. And also it has other options like animated properties. And it also has this inner glow effect, so you can achieve this kind of glowing holographic object easily. So all of these are achieved by the single shader. And also, there's an option called rounded corners, so you can easily achieve this kind of the geometry transformation. So these are all procedural effect. So yeah, it's really fun to play with. Then another great element of this new shader is that it can achieve this smooth fade-out effect for the clipping distance. So in default, in mixed reality camera, the HoloLens, this option called a near clip distance has a 0.85 meter in default. This is kind of the recommended default value for the user comfort. So it clips out the holographic object when you get closer than this 0.85 meters. But it shows this hard clipping effect. But if you want to make it more smoother fade out, just decrease this value, then go back to this material of this object. Then in the shader, there's an option called near plane fade. So when you check it, as you can see, there's a fade options, fading start, begin, and complete distance. Then, as you can see, it becomes black when it gets closer. So black means in HoloLens and transparent. So as you can see, you can achieve this kind of more natural, beautiful effect. This one is a default one with a hard clipping effect. So yeah, this is a kind of the effect that you can achieve with this new shader. Next, tooltip and animation. So tooltip is quite useful when you want to describe or annotate the object. So for example, you can describe the button functionality in the motion controller, which is one of the most widely used pattern in VR. And also you can use it for annotate or labeling an object in HoloLens. So it supports flexible pivot and anchor system. So you can find examples under examples, UX, and scenes. The name is tooltip examples. So using it is quite easy. So prepare any object, then just drag and drop the tooltip prefab into the scene. Then in this prefab, you're going to get these options. So you can type the text label. And under this tooltip prefab, you're going to see this. There's a tooltip connector, and there's a field called target. So you can just drag and drop this target object, and it automatically creates this kind of the lines between the object and the label. And you can control the anchor and pivot in the editor. And in the example scene, I also have added this the layout for this motion controller. This kind of template so you can use. So when in the editor, when the motion controller is detected, it will automatically attach to the left and right controller. Then you can easily update the text for your purpose. So next, dialog and progress. Dialog is standard UI to display the notifications, or when sometimes it requires approval from the user. Then it shows us this dialog with the animation. Oh, somehow this is not playing. So yeah, the dialog is a good example is when you have a voice input capability in your app, then it displays this kind of the approval message for the microphone access. Then the progress is a kind of loading indicator collection. So you can use it when you want to display the kind of visual feedback when the data loading is happening. So you can find the examples under example, UX, and scenes folder. And when you look at this dialog prefab, you're going to get this 1 or 2 button options. So to use it, just simply just access this dialog prefab, and in the script, you call this dialog.open. Then you can subscribe to this dialog.onClose event to get the result text. So this way you can understand which button was clicked in the dialog box. And the progress prefab has these all different types of the loading indicator. So in default, it has this animated Windows default style, animated orbs. And also you can add your custom prefab object. Maybe you can add your own logo. And also there's a progress bar style and also text only. And when you look at the prefab, it contains all these different types of objects. So basically, depending on this style type, it shows and hides different components. Using it is quite similar to the dialog. For this progress indicator object as an instance, just using this open function, then you can open the progress indicator. Then inside this coroutine function, you can update this message and progress using this progress indicator instance this set message and set progress. And to finish the loading indicator, you can simply call this a close function. Then inside this coroutine, you can finalize this dialog progress indicator. So yeah, there was a lot of items, building blocks. So these were some of the useful building blocks in MRTK that I wanted to introduce today. So I hope these building blocks can help you quickly and easily create Windows mixed reality experiences. And of course, I don't think this is a kind of the end. This is a really great starting point. And I'm sure you can bring your own ideas and creativity and build magical interactions. So I can't wait to see what you can build with these MRTK's building blocks. So Mixed Reality Toolkit is community-driven open source project. So we've been working with amazing developers outside from Microsoft. And so especially with this MRTK version next effort, we'd like to invite you to join the community and make it better together. So there are multiple ways to contribute to MRTK. So you can simply just use it and file a bug by opening an issue on GitHub. And of course, you can suggest a new feature or improvement. And of course, it'll be amazing if you can implement a new feature or bug fix and submit a pull request. So this is a kind of the typical GitHub contribution process for the people who are not familiar with this. So you can just open an issue and make a proposal for the bug fix or any suggestion. Then implement the proposal. Then when you do this, it is important to have a proper example or a test scene with a proper README file so that other developers and creators can understand what's happening there. Then open a pull request with the proper target branch. Then address comments from the reviewers. Then finally, when it's get approved, then it's going to be merged. So in terms of the branches, we have this master branch, which is the official release branch, but it's always locked. And you have this monthly dev branch. So basically, we are targeting kind of monthly release for this MRTK. And so you can use this monthly dev branch to contribute your code. And this development branch will be deprecated sometime soon. And so we have this MRTK version next branch, which is kind of the new version of MRTK we are working on. So basically, the idea is that we want to support multiple devices and other platforms too, and make current input system more flexible and modular and extensible. So that's the MRTK version next effort. You can find more detailed information on the GitHub. When you click the project tab, you can find all this history and the documentation. So I'm going to skip this part, again, the contribution part, flow. So yeah, as I mentioned earlier, when you go to this Mixed Reality Toolkit landing page, you can find all this release information and the Unity version and the core features and all these example scenes. So most of the building blocks that I talked today, you can find on this landing page. And it leads to the README file that shows all the technical details and the backgrounds. And these are some of the other great resources that you can find on our Windows Mixed Reality Dev Center. So the shortcut is aka.ms/mr. So when you go there, you can find the Mixed Reality Academy tutorials and development and design guidelines. And recently, in this Mixed Reality Academy tutorial, we have added this new series for Mixed Reality plus computer vision and machine learning. So in this series, you can find how you can use HoloLens or mixed reality devices for machine learning, the computer vision, face recognition, and language understanding. So really interesting topics. Somehow, my computer just got froze. So yeah, that was kind of the last slide that I have. This my information. So yeah, you can find these building blocks also on the Medium article. I have published this article called Open Source Building Blocks for Windows Mixed Reality Experiences. So you can search on this Medium. And yeah, this is my Twitter handle and the Medium account. So you can search this ID. Then I'm also sharing some of the personal story on my HoloLens and immersive headset projects. So you can check it out. Yeah, I think we have like 10 minutes. So thank you very much for joining the session. So yeah, if you have any questions, just let me know. Any questions?
Hi.
Hi.
I was wondering if you could say anything about the future or the intended future of the toolkit.
Oh, the Mixed Reality Toolkit. As I mentioned, initially this Mixed Reality Toolkit was started with the Holo Toolkit to support HoloLens. Then later we expanded to support immersive headset. So because of that, honestly, all this input system, other modules are not that flexible and extensible. So we got a lot of feedback from the community developers and internal teams, and so we wanted to make it more modular and extensible. So that's the kind of new effort on the MRTK version next. So you can find the branch, and you can find all the detailed project, the planning and the documentation and the designing of the architecture. So definitely for this MRTK version next, I'd like to recommend you to look at it and also contribute to that kind of new design. We also wanted to make sure it is really kind of the extensible and modular that can support other platforms too. And in terms of the release plans, I think I heard that they are targeting kind of sometime in July for the initial alpha release. So that's going to support for basic input features like gaze, gesture, voice, and motion control support. Then once it's ready, I think we're going to also bring all this kind of existing building blocks to version next to support. And the version next is because we're completely rewriting all this kind of input system and architecture, so it's not going to be compatible with the current existing MRTK. But definitely, we want to make sure all this kind of transitioning is easy and doable. Yeah.
Okay, great. Thank you.
Yeah. No problem. Any other questions?
Hi. Thank you for your presentation and also for your work. I
thanks.
Appreciate it. I have two questions. One is, do you have some tips for shadows on HoloLens? Like shaders which creates shadows in the real room. And the second one is maybe like the time schedule for when the Holo Toolkit, Mixed Reality Toolkit will be on 2018 to Unity.
Oh, yeah.
A hard question. No, I don't know what to push.
Yeah, so definitely we'd like to support Unity 2018. And I think actually it currently runs on 2018, but when you do it, it upgrades some of the shaders and other components. But I think it is working actually with the 2018. And yeah, as I mentioned, definitely the Mixed Reality Toolkit version next will be based on 2018. But current MRTK, we are kind of, because we have a lot of existing users from old version of Unity, so we wanted to support this old version too. So yeah, that's that. And for the shadow, because the black means the transparency in HoloLens, it's not possible to actually add the black color, but you can definitely use a more lighter gray value to achieve the shadow. And also you can kind of reverse those kind of shadow effects by just adding more lighter, brighter color below that holographic object. So you can, even though the shadow is not the dark, even it's a more lighter color, but still gives you kind of the perception of that it has some kind of shadow effect. Yeah.
Okay.
Yeah.
Thanks.
Yeah, hi.
Oh, hi.
I have a somewhat special use case. I want to actually bring multiple mixed reality devices in one room and share the play space. So this is actually possible with HoloLens, with a specific server or something like that. But is it possible like sharing the play space of multiple mixed reality devices, like bringing the play space over to another PC and then using the same like zero position for sharing like multiplayer experiences in the same room?
So about 2 years ago at Build conference, we had this demo that has a multiple immersive headset and multiple HoloLens in the same room and sharing this kind of experience. But it was a little bit different because the HoloLens has a different view, kind of bird's eye view, and the immersive headset was kind of exploring the island inside as a kind of VR experience. But so yeah, you can find that code, the island demo on the Mixed Reality Academy, and as a tutorial.
I saw that.
Yeah.
But problem is, or what I want to achieve is actually having the real head on the same position like the virtual head.
Yeah.
If your other part is like in the same room, and his virtual avatar is on the same space like his real head.
Right. So that's going to be about really designing the kind of virtual environment, same as the actual physical environment. I saw some of the people are doing kind of using the HoloLens to scan a room and reconstruct that environment with the meshes. So I think that could be also kind of the potential possibility. Maybe you can bring those kind of real-time mesh back into the immersive headset device and inside the scene. But I don't know if maybe the quality would be not that great. But yeah, from scratch, I think if you have a kind of specific space, then maybe you can just design the VR version of the space, just like a physical environment. Then from there, maybe you can start constructing the experience of using it with the shared coordinate. Yeah.
Okay.
Yeah, thanks. Any other questions? So yeah, definitely, I'm gonna stay around here. So if you, after this session, if you have any questions, just let me know.
I have a question. Hello.
Yeah.
Thanks for the talk, by the way. It was
Thank
really
you.
good. Are there plans to actually introduce hand occlusion in one of the next versions, maybe, of the MR toolkits?
You mean?
Yeah, so at the moment, if you raise your hand, then you will always destroy the immersion because the holograms will be rendered in front of your hand.
Yeah.
So it would be cool to have kind of a
Yeah.
occlusion of the hand so that you can actually interact more
Yeah, I
naturally.
think that's
with
going to
the-
be more about the hardware side design challenge. And yeah, I'm not sure if he have this kind of planning. Even I cannot talk about the new device. But
Okay.
so yeah, I'm not sure. But in the toolkit level, I don't know if the device can support it. Definitely in the toolkit we can provide this kind of to the developers. But I don't know any plans for that kind of occlusion support. Yeah.
Okay, thanks.
Yeah. So great. Thank you very much for joining the session today. Yeah, I hope you can build amazing experiences with MRTK, and yeah, I hope we can also meet on the GitHub community as well as other HoloLens developer channel, like a Slack channel and the Facebook community. Thank you very much.